Hey everybody, today we have a Black & Decker 12-volt cordless drill and we're going to disassemble it. So first steps first, for safety purposes, and it's just the first natural step, is you have a removable 12-volt battery here, and it's pretty easy. They have a button here you push down on and it automatically pops it out. You can kind of see down there inside there's some springs that allow it to just pop loose once you press down on that button, and then you can go put that on the charger, set that aside for now, because now we'll begin taking apart the actual drill. And to do that, all that's holding this together is two pieces of probably injection molded plastic on each side. You can kind of see it split down the middle, and then we have what I believe is 9 screws kind of centered around the body holding it all together. 8 of them are the same, about a number 1 size Phillips head screw, but there is one small kind of number 0 Phillips head size screw located towards the back. So for the next step, we'll need 2 tools, a number 0 Phillips head screwdriver and a number 1 Phillips head screwdriver. So we're gonna get those and we'll be back.
As I just mentioned, we'll need 2 screwdrivers for this next step, a number 0 Phillips head and a number 1 Phillips head. As the disassembly process continues, we'll also need a small flat-headed screwdriver or something you can use to just pry open a little tab a little bit. And then finally, a small crescent wrench, or I used a pair of needle nose pliers as I didn't have the correct sized wrench.
All right, now we're back. I misspoke just a little bit. We have 7, I believe, are number 1 size Phillips head screws. So 1, 2, 3, 4, 5, 6, and 7, and then 1 number 0 Phillips head screw. So we're gonna go ahead and take those out right now.
If you're doing this yourself at home, here's a better look at the location of the 7 screws.
So number 1, slightly larger Phillips head screw. Again, you wanna use the right Phillips head screwdriver, because otherwise you'll strip out your screws and they'll be tough to either finish removing or tough to get back in or remove in the future if you strip out those Phillips heads. And make sure when you are removing the screws that you put them somewhere they're not going to get lost, as they are small, dark colored screws. They're easy to drop on the floor and disappear on you. Two. 3. 4. 5. 6. 7. And this last one, number 7, is pretty deep into a kind of a counterboard hole there. So we might have to get that number 0 out and then pull it apart, because it's not wanting to just drop out. It's kind of still stuck on a last thread or stuck inside the slip foot hole there. So I'm going to switch to our smaller screwdriver, kind of a number 0 Phillips head again, to get this back screw here. It's quite a bit smaller than the other one.
Again, if you're doing this project by yourself at home, here's a better look at where that screw is located.
And again, we're doing that so we don't strip out the screws, and we can get it out without damaging it, so we can put it back in later. Kind of shimmy this guy loose. Ooh. Like I said, you got to be careful with those little screws. They like to pop out. Yep. So now we have the object in pieces. So I'll stop the video and give you a better orientation. We actually might be able to show you here without too many things dropping out. But yeah, here is the inside of your 12-volt Black & Decker drill. The side I just pulled off is just pure plastic, nothing on this side. other than the frame portion of it. So we'll be right back after I find the little screw.
While we wait for me to find that small screw, here's a better look at the internals of the drill. Like I said, up top you have your chuck assembly, followed below by the trigger assembly with the battery interface down below.
All right, back again. So again, we took off the other piece of plastic injection molded part that holds the whole frame together. And so now all the internal components are housed just in this bottom piece. And holding everything into the bottom piece really is nothing. It's just a well-designed injection molded piece of plastic frame where everything kind of sits nicely where it needs to be. So really everything kind of just pulls up. Be careful when you're pulling things up. The battery's out, so there's no power, so you don't need to be worried about getting shocked. But you don't want to get pinched by anything or damage any of the wire solder. So yeah, if you can kind of see this, we got our DC motor here, and then the assembly that houses our chuck and drill piece with the 11 different modes. So then we carefully pull up all the wires, pop out the light, and there we have basically our entire internal assembly, all connected by the different wires. And that leaves us with the other piece of injection molded plastic. We do have this little switching piece here. This is the switch that allows you to go forward or reverse on the direction of the drill. And you can see it's just a little piece of plastic. So we'll set that off to the side, as well as the other piece of the frame off to the side, leaving us just with essentially 3 sub-assemblies connected by wires. The bottom one here is where your battery connects. Again, we showed that earlier. We got these springs, and then the leads are these little metal pieces that allow your device to be powered through the different wires. So you have 3 wires, again, positive, negative, ground. You have your light at the bottom, again, soldered physically. You have a couple screws holding the trigger mechanism together. Inside the trigger mechanism, you're gonna have your PCB board, your electronics, kind of the brains of the system. And then up here is really just a mechanical system. You have a DC motor and then the chuck assembly. So we'll take a break here and then we'll come back and we'll start taking these pieces apart. All right, so now we'll start at the bottom with our 3 different sub-assemblies here and work our way up. So the bottom assembly, we're really not gonna take anything apart out of. These leads look to be press fit in there, so if we take them out, they'll probably be difficult to get back in correctly. The springs, I think, are in there with some kind of adhesive, so if you pull them out again, you're gonna need to replace the adhesive. So this little bottom sub-assembly that houses our battery, we're gonna just leave together. Again, very few parts, pretty simple. Shouldn't really be having any trouble with those components in your drill, and if you are, you may be able just to replace that whole sub-assembly, but the challenge there is you'll need to solder your own wires back in. So moving up from there, now we have the trigger mechanism. And so holding the trigger mechanism together is you have a little screw here and another Phillips head screw here, both Phillips heads. I think both will be able to be removed by like a number 1 Phillips head. On the back of the screw on the bottom, there is about an 1/8 inch nut holding it to the plate. And the other one, there's just some internal threads holding it in. So those 2 will have to be removed. And then after those 2 are removed, this plastic box here that holds the PCB is just a snap fit box. So we have about 4 different locations where there's little, hard to see in the video, but little plastic clamps that just kind of have an interference fit. So you take the clamp and you pull it over and it snaps in. So there also used to be one on the top, but I've done this once before and broke that snap off the top. So be careful taking that apart. Not all of them are needed, but you break enough of them and the lid won't stay on very snugly anymore. So I'm gonna go ahead and start removing those screws. We'll start with the internally threaded one, as that'll come out real nice. Again, set these somewhere in a bowl or a glass just to make sure they don't get separated. Sometimes I like to take a piece of paper and label where they came from if you're taking apart something that's quite large or has quite a lot of fasteners, so you remember where they come from. So yeah, I was able to start this screw with a nut. Now we got the nut spinning. So I would say you need probably about an 1/8 inch crescent wrench or an 1/8 inch wrench of some kind. I don't have anything that small, so I'm gonna use a pair of needle nose pliers to hold the backside. Again, be careful not to pinch any of your wires. This is gonna be a little clumsy again because I don't quite have the right tools. But holding that nut, you should be able to take that screw right out. So there comes the nut off in dramatic fashion. So there's a tiny little nut. You have a screw, and there's even a washer on it. Looks like a split washer to keep it in tension. If you can zoom in and if we can see that. So small it's hard to hold, which is an important factor in design for manufacturability. Smaller screws, more difficult to handle. So yeah, then our little protector place holding the trigger mechanism together comes off. Set that aside. And that just leaves us with the kind of clamps on the trigger mechanism. So I'm gonna go ahead, and this is where you can use a small flat-headed screwdriver. Again, don't pry too hard. It's not on there with a lot of force, but you just need to lift it up and push the latches over. Without breaking them is the careful part. Kind of heard it start coming free there. Go. One side's up and off. The other side snapped back down while I was doing that. There we should be free. And there it goes. Except there is kind of the front cover of the plastic trigger mechanism guard. And I think that, and we'll pause there for a second while I examine and see if we can get this apart any further. Hey everybody, I'm back. I wanted to further evaluate this whole trigger mechanism a little bit more, make sure there was nothing else we could really take apart here. For safety's sake of my drill, to make sure it continues to work, it looks like this PCB board here, the printed control board again, which is kind of the brains of your operation, controls how your motor spins based off of how you're positioning your trigger. It's pretty well embedded in this plastic. It's pretty well connected to this trigger mechanism. If you have issues with the electronics here and it's not something that's simply solderable or broken links, you're probably going to need to just replace the sub-assembly. It's not something that's easily fixable. So that would be my recommendation. This back part, the back frame is pretty well embedded. You can kind of look at the bottom here. If we pull these wires out of the way, everything's pretty well embedded within this frame, kind of directly adhered to the plastic frame. So there's nothing really more we can do here or take apart here. But the one thing I wanted to call a little bit of attention to is we have this little switch here. This is what drives your forward and reverse motion. So if we bring back that little plastic piece we took off earlier, that kind of sits on here, and as you push it forward and backwards, it flips a switch on the PCB telling the motor which way to turn, whether forward or reverse. So with that, we'll move on to our next step, taking apart the mechanical mechanism that gives you that power to drill or screw or do whatever you're doing with this great Black & Decker 12-volt drill. All right, welcome back everyone. Again, now we're gonna start taking apart our 12-volt Black & Decker kind of mechanical mechanism that does all the drilling and driving. So again, I don't know if I mentioned it in the last section of the video, but be careful of the wires. You don't want to pinch a wire or cut a wire, or you're going to be doing some unthreading of screws, which is pretty safe, but you don't want to accidentally put your elbow down on a wire and pinch it or cut it. So just be cognizant of where this whole mechanism's at, since it's all kind of still connected. because these wires are just soldered on. So the first step we're gonna take here is we're gonna separate the motor. So by taking the motor off first, we can kind of move all this wire off to the side, and we can really focus on the internal mechanisms here, which there will be some gears and ball bearings in there that we'll need to be careful of. So that'll be the first step. And so to take the motor off, we have these 3 screws around the edges, which are a little difficult to get to. You kind of have to angle your screwdriver. The motor's also got some magnets in it, so you can see my screwdriver likes to stick. But so this black plate, you can kind of see there's a thin line there, will pop off with the motor, and then we'll just be left with the remaining piece of our chuck. So we're gonna go ahead and we'll take these 3 screws out.
Here is just a slightly better look at the screws I'm removing here to take off the DC motor. Note that there's 2 arrows, 2 screws, but there's also a third one kind of in a triangular pattern on the back side that is not visible in this photo.
There's one. And there we have it. There is your DC motor. There is still an interface here that is not part of the COTS motor, but we'll just leave that on. There's also a washer. There's 2 bolts that hold this plate on. You have your little gear here. It's quite greasy, so I'm not gonna take that off right now, but you can see there's your drive gear, a plate to mount your DC motor onto the mechanical assembly, and then below that is really just a standard off-the-shelf DC motor, nothing special, just the one Black & Decker has chosen. You can kind of see there's even oh, it's hard to read if I can get the camera to focus. There's even a COTS part number right stamped on the DC motor. So we'll take a break there, and then we'll start disassembling the next section. So I wanted to say briefly here, I did take the 2 screws out to remove this connector plate, but again, as I said, there's nothing too exciting. You still got your drive gear, and this is just, again, the COTS motor. So you can turn that around. Yeah, just a injection molded plastic plate that sits on there so you can connect your motor to the other mechanical assembly. So the next portion of this video is looking at this chuck subassembly. So again, you kind of have some movements here where you can open and close the tongs here without the motor installed. There we go. There we go. It's opening and closing. It's a little bit different. You have to be careful because now the gears on the back side don't have anything holding it in. So these things will just slide right out, and they are greasy. They do have grease and oil on them to keep them well lubricated. So I'm gonna go ahead and take these out. I'm gonna roll up my sleeve some, but I would recommend using some latex glove. I just don't have those at the current moment, but that would be the proper way to do this. But since I don't have that, I am just gonna go for it and wash my hands later. So you can see, you can just, first of all, I'll show you how they spin. So it's a planetary gear system. to transmit all your different kinds of motions, because you can kind of hand turn some of this stuff, and then obviously when you hit the trigger, your motor is going to turn and apply force, apply torque. But yeah, you can just pull these out. Again, with the screws, make sure you put these down somewhere where you're not going to lose them. They're kind of important. Maybe on a piece of paper. Limit the grease you're getting on the table. So there's 1, 2, and 3 little gears. Then you can start pulling out the whole kind of outer shell. So you get that outer shell pulled out. There's kind of a central transmission gear in there, and what just fell out was a ball bearing. So I'm going to set this down really quick without trying to drop out too many of the gears. So in there, kind of on the bottom, we have a bearing that everything sits on. So in that bearing, there are little ball bearings that will need to be put back before you reinstall. So again, kind of small, tough to deal with. You really should never have to be replacing these on a drill, but that is a ball bearing. Don't let it roll away like I just did. Luckily it didn't fall off the table. And they're slightly magnetized because of probably all the magnetic forces. But yeah, they're made out of some type of iron, since they're magnetic. At least a high concentration of iron. So there you go. So don't lose those ball bearings. We're gonna set those guys off to the side. That guy off to the side here. But yeah, I believe there's 6 in there. So there's kind of 5 more that are stuck in there to the bottom plate. And then those 3 prongs sticking out go into our 3 metal gears here on the back side. And that'll be the next step, is to get those taken out. So with those taken out, we can work on removing our base plate here, kind of the middle portion. So again, that's pretty greasy, but there's a central kind of drive gear. Again, this guy's kind of turned from the plastic planetary system, the gears we already took out, and then the external gearing on the chuck. And then this is the drive gear for the other side. Set that down. And then from there, what we have is 3 embedded metal gears, just the exact same size as their plastic counterparts. These guys are metal, probably because they probably take on quite a bit more torque as the drill operates, and then that's transmitted through the planetary gear system. While you can use plastic on the other side, but we'll take a further analysis of that later. But yeah, then you kind of have your housing and all your different gears. So I'm going to set that aside, wash my hands, and we'll take a further look at what's left in our assembly.
While I'm on this little break, I wanted to provide a photo of what that planetary gear system looks like. So when you open up your chuck, you know what you're getting into. Again, the outside, you have your ring gear. Inside that, you have the 3 planetary gears. And in that's where you have your kind of central intermediate gear, sometimes called the sun gear, that everything's rotating about. Again, there's some metal planetary gears on the backside and some ball bearings. So as you remove those things, be careful so they don't fall out and get lost.
All right, I'm back. I got my hands all washed. We're gonna have to get greasy again when we put it all back together. But I wanted to finish out the disassembly video for you. So here we have the chuck. So again, we've got our 11 different speeds. So there is definitely some mechanisms going inside of here. But the pieces are quite a few of them are press fit together. There's probably some retaining rings in here holding the different, plastic sections together. So for the sake of my drill and usability in the future, I'm going to leave this intact. A lot of these plastic pieces, probably injection molded. I don't think you'd machine them. I mean, it is a cylindrical part, so you could theoretically lathe them, but they also have little stamps on here saying, lock, unlock, 1 to 10 millimeters. I'm looking for some markings to show that they were injection molded, but I'm not seeing any just right off the bat, but they're probably on the inside as the plastic flows into the mold. So yeah, again, to show you, we have the inside portion where your metal gears will attach to. There's some ball bearings that go around there. Inside of this part, you'll have the controls for what setting you're on, probably another set of gears, kind of, it's a clutch mechanism to determine the kind of gear ratio you're getting to evaluate the amount of torque. You can see maybe that there's a little metal ring, kind of, it's like a ring spring, and that is what selects essentially the gear you're in. So you can kind of hear the click. That's me moving to some of the other gears. So again, we're gonna stop here for the video, but you've seen everything essentially taken apart as low as can go, with the chuck remaining in its intact state. So I appreciate you being here with me. We have kind of a quick demonstration. I'll show you the parts. So yeah, we have all our parts. We started with, the 7 number 1 Phillips heads, the 1 Phillip head to, I guess that goes there. The thinner Phillips head for the frame. You got your internal plastic gears, your ball bearings, your internal gear, the metal gears on the backside, the housing for your planetary gear with the gears itself, cover for your PCB, screws for the plates to hold your PCB in place. These were the screws for the motor, your chuck as discussed, your battery mechanism, trigger mechanism, DC motor. That plate does come off pretty easily just under that metal washer. Then you have frame piece, trigger, and then finally the 12-volt battery. So thank you again so much. This has been a disassembly of the 12-volt Black & Decker drill.